this segment, we're going to learn how to convert numbers from different bases into base 10 numbers. Base 10 numbers are what we're familiar with, so we love them, and we find the others hard to understand, so we want to know how to convert the others. Before we do that, we're going to take a little walk down memory lane back to 3rd to 4th grade when we talked about place value. Let's look at a base 10 number, 42,368. So what did we do here? We have 8 here, and this is base 10, so I'm going to go ahead and write a 10 down there to remind us. This is base 10, so this is 10 to the 0. Remember, anything to the 0 power is 1. Then this one is going to be 10 to the 1, which is 10. And this one's going to be 10 to the 2, which is 100. So this is the ones place, this is the tens place, this is the hundreds place. What comes next? Thousands and 10,000s. Well, 10 to the 3rd is 1,000. And 10 to the 4 is 10,000. So whichever way you find helpful, if you think it's easiest to start with the base and say to the 0 power, to the 1 power, to the 2 power, to 3 power, 4 power, do that. I actually kind of find it easiest to say, okay, I'm going to always start with 1, and then I'm going to say 1 times the base for the next place value. Then that times the base for the next one. So 10 times 10 is 100. 100 times 10 is 1,000. 1,000 times 10 is 10,000. But that's really what we're doing here by adding the powers. So how would we really write this number out? This is 4 times 10 to the 4th, or if you'd rather, 4 times 10,000. And then we're going to add it to what? 2 times 10 to the 3rd, or if you'd rather, 2 times 1,000. Then we're going to go to the next one, this one. 3 times 10 to the 2, or if you'd rather, 3 times 100. And we're going to go to the next one. 6 times 10 to the 1, or 6 times 10. And then the last one, 8 times 10 to the 0, or 8 times 1. And if we add all those numbers together, we get our base 10 answer, which is 42,368. So we're not really doing any converting in this example. We're just showing base 10 number, or how a base 10 number adds up by its place values. Okay, when we convert numbers, we're going to do this exact same process, except we're going to be starting here with a base other than 10, so that when we go to this process here, we're converting them to 10 by talking about the number in whatever base it is. Okay, so let's look at an example. Let's say I have the number 57, base 8. Okay, so this number right here, the number 7, is in the 8 to the 0's place, or the 1's place. The 5 is in the 8 to the 1, or the 8's place. By even writing an 8, I'm writing in base 10, not base 8, because remember, you can't write base 8 in base 8. So when I say this is 5 times 8, 5 times 8, plus 7 times 1, I am writing that in base 10. What is 5 times 8? 40, remember, order of operations tells you you need to multiply first. I put them in parentheses to remind myself of the order of operations. Plus, be careful, these x's are times, they're not variables, so I could use dots instead. So this is 47. So I end up with the fact that 57 base 8 is the same as 47 in base 10. Okay, let's do another one. Let's convert 324 base 8 to base 10. Okay. So I have 324 base 8. This is the 8 to the 0, or the 1's place. This is the 8 to the 1, or the 8's place. This is the 8 to the 2, or the 64's place. Okay, so I'm going to take the number and multiply it by its place. So 3, I'm going to use a dot this time. 3 times 64 plus 2 times what's its place value, 8 to the 1, or 8, plus 4 is in the 1's place, so 4 times 1. Okay, 3 times 64, so 3 times 4 is 12, carry 1. 3 times 6 is 18, 19. 2 times 8 is 16. 4 times 1 is 4. Now let's add these. See, 4 and 6 and 2. 1 and 9. It's 10, and that's carried to 202. Most calculators, you can do this all in one step. 3 times 64 plus 2 times 8 plus 4 times 1. As long as you have a calculator that does order of operations, it doesn't have to be one of these fancier graphing ones. You can do it all in one step. And did I add wrong? Looks like I did. Add wrong. 212 base 10. We'll do better with our crutches, don't we? 324 base 8. It's the same thing. It's 212 base 10. Okay. Let's try another one. Let's try converting 312 base 5 to base 10. Okay, so if I'm going to convert 312, let's start with 312. 5 to the 0, 5 to the 1, 5 to the 2, or if you'd rather, the 1's place, the 5's place, 5 times 5, and the 25's place. Okay, so let's multiply 3 times its place. Each number times its place. So 3 times 25 plus 1 times 5 plus 2 times 1. 75 plus 5 plus 2, which is going to be 2 and 5 is 7. So that's going to be 82. So 312 base 5 is equivalent to 82 in base 10. Okay. Let's try base 2 number. Base 2, which is also called binary, so we could call it binary, and we want to know what it is in base 10. Let's write that word over here, binary. Bi meaning 2. I like bicycle and so forth, bifocals. Okay, so we have the number 1, 0, 1, 1, base 2. So if you like using the powers, 2 to the 0, 2 to the 1, 2 to the 2, or 2 to the 3. Or 2 to the 0 is 1, 2 to the 1 is 2. Now multiply 2 times 2 is 4, 4 times 2 is 8, so on. So we're going to multiply each number by its place value. So 1 times 8 plus 0 times 4, plus 1 times 2, plus 1 times 1. So I get 8 plus 0 plus 2 plus 1, which is 11. So 1011 base 2 is the same thing as 11 base 10. Wow, a lot of digits to write the number 11. Let's try a bigger one, and you'll see that's even more true. In fact, let's let you try it. 1, 1, 0, 1, 0. Why don't you pause this and see if you can convert this to base 10, and then start up again and see if you've got the same answer that I've gotten. Okay, 1, 1, 0, 1, 0, base 2, 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4. So we start with 1, 2, 2 times 2 is 4, times 2 is 8, times 2 is 16. And we're going to multiply each number by its place value. So 1 times 16, 1 times 8, 0 times 4, 1 times 2, and 0 times 1. This one is actually easy, the binary ones, to convert without writing that second step, and just see if it's times 16, 1 times 8, plus 0, you don't even have to write that one if you don't want to. 1 times 2, and 0, so 2 and 8 is 10, so that's 26. So 1, 1, 0, 1, 0 base 2 is the same thing as 26 in base 10. Okay, what about 312 base 4? Try that one. What would it be in base 10? Okay, 312. 4 to the 0, 4 to the 1, 4 to the 2, so that would be 1, 1 times 4, 4 times 4, 16. So let's have each one multiplied by its place value. So 3 times 16 is 1 times 4, is 2 times 1, 3 times 16 is 48, 1 times 4, 2 times 1, so that's 6, and 8, that's 54. So 312 base 4 is 54 base 10. We want to make sure we get a base 16 in here. So let's look at a base 16 example. 1A8 base 16. 16, by the way, is known as hexadecimal, or sometimes just hex for short. So sometimes we might actually write a little word hex down here instead of a 16. So let's see if we can convert that to base 10. Okay, 1A8. So this would be 16 to the 0, 16 to the 1, 16 to the 2, 16 to the 0 is 1. 1 times 16, 16 times 16, 256. So I need to multiply each number by its place value. 1 times 256 plus A times 16 plus 8 times 1. What? A times 16? What is A? I can't use A. Let's think about this. When we're counting 8, 9, A, B, C, D, E, F, really this is the same as 10. 11, 12, 13, 14, 15. So A really is what? 10. So that second one's going to be 10 times 16. So 1 times 256 plus 10 times 16 plus 8. Let's not risk making an error here, and I'll use my calculator. 256 plus 160 plus 8, or I could have done the whole thing in my calculator. 424 by having it do the multiplication and the addition. So 1A8 in base 16 is the same as 424 in base 10. Okay. How about dB, base 16? What would that be in base 10? Well, let's start with 16 to the 0 and 16 to the 1. That would be the 1's place and the 16's place. So I'd end up with D times 16. But I'm using the dots. D times 16. And B times 1. But I can't use D and B. D is really 13. And B is really 11. To look up here and see D and B. So I really have 13 times 16, 208, plus 11 times 1. So that's going to be what? 219. So dB base 16 is 219 base 10. And let's try one more. Let's do a base 12. Say you have 82 base 12. What's that going to be in base 10? Let's go ahead and make it 382. Okay, so I have 382 base 12. I'm going to start with to the 0 power, to the 1 power, to the 2 power. Always starting with the 1's. 1 times 12, 12, and 12 times 12, 144. And we'll multiply each of these by its place value. So 3 times 144 plus 8 times 12 plus 2 times 1. Do the whole thing. 3 times 144 plus 8 times 12 plus, 2 times 1. Three times 144 is 432. 8 times 12, 96. And I should get the same thing if I add these. 432 plus 96 plus 2, 530. So 382 in base 12 is the same as 530 base 10. So I'm just using the place value. The next segment will go the other way. We'll start with base 10 and convert to the other bases. That also is not difficult. The thing you have to be careful of is keeping straight which method you use in which direction. So we use place value when we're going to base 10. We're converting to base 10. We use the place value.